Okay, here is first a quick question. Okay, sorry, I'm like trying being very asking too many questions. Maybe not allowing you to think. But just please answer this question. So there's that one side is parallel. Okay? You can see what's parallel to what. And this is also parallel to what you understand, the opposite side. Does it imply that this is third side is also parallel? Yes? Any opinions? So AF by FP. Okay, what am I saying? Check it. FP is parallel to BC and ED is parallel to AB. These two are given. What can you say about FT? You can look at the angles and see if you think that is correct. AF by FP equals to AE by EC. That's because FE is parallel to BC. And then this AE by EC is equal to BD by TC, because start with AE and EC, so we have to go again bottom and EC. So then what? AF by FP is equal to BD by DC. Does it imply? No. Okay? That doesn't imply. Can you make an example? Do you guys see that it is no? The answer is no. Because we don't get it, right? We have this AF by FP, right? It should be DC by BD, but it doesn't happen. The opposite happens.
Sir, only in the special case where the midpoints it will be true, right?
Ah, right. Otherwise, it will not be true. Right. Because when they are the midpoints, then 1 by 1 is still 1. Yeah, otherwise it is not true. And you can, I suppose now we can see it. It's not true. Okay. So otherwise the problem would have been too easy, that last problem. So let's go there again, and I should have saved the diagram at least. Yeah. So let us see. We have observed that this is a rhombus. Yeah, this looks more like a rhombus. 90 degree means it's a rhombus. This itself, all these angles. Four, 5, AC is 6. Chalo, do the calculations. Or if you can find a good way. So that perpendicular, you can maybe use that. So we need to find ED, right? So any progress?
Sir, I think we have drawn the measurements wrong.
Ah, so what are they?
AB was 5, AC was 4, and BC was 6.
Oh, okay. That's okay. I change this. AB was 5. Okay, it was coming like this. Oh, so this was 5. Yeah, but I think that would not matter. AB was 5. BC was
6.
BC was 6, and AC was
4.
4. Oh, it was opposite. Okay, so then the figure is not like. But I don't think that really matters. The length really matters.
So from this, can we say that AF will be 2 and FP will be 3?
You mean with this labeling? AB 4, 5, this current labeling?
Yes, sir. No,
Oh,
like according to the question, it was
according to the question. Okay, so let's go
length.
according to the question. So, okay, again, I've forgotten the length. Okay, I just write it here once and for all. AB is
Sir, phi AB is 5, AC is 4 and BC is 6.
right. Okay. So with that, what are you saying?
Sir, so AF and AF is by FB will be equal to AC by BC.
Yes.
So,
So that's the angle
because we
bisector
know,
theorem. Yeah.
yes,
Does everybody know that? You have to use such things in these questions. Right? Otherwise, it takes a longer time. So with the angle bisector theorem, when you bisect this angly, when you bisect this, the ratios sort of also get bisected. Right? So this thing, suppose just a like thing separately there. This AB by AC, this will be the ratio of the bases. Yeah, and write that. So with that we are using, and that you have to kind of thing you have to use. Okay, so then using that, what do you get? You're getting AF and FP something.
sir, AF is 2 and FB is 3.
Okay. Right. Yeah. Similarly, we can find all of them, see what they come out to be. That is very useful. I mean, I don't have a good way to do the question. Okay? See, here is the idea so far. You can find all the lengths. Okay, you can find all these lengths. But most importantly, what maybe we can focus on is to apply Pythagoras theorem. I'm just saying this on this. Like, what is the idea in this diagram? Look at this. I'm trying to apply Pythagoras theorem on this. I will try to use like find FE. FE is very simple to find. Okay, because FE by BC, right? That is 2 by 3. Already know that, or not 2 by 3, 2 by 5. Right? Smaller triangle, bigger triangle, 2 and 5. It's 2 by 5. You know BC and 6, so you can find. And the answer will come in square roots. That's why they're asking us to square. So FE can be found out. Any ideas how we can find Fx? See, finding Fx should not be easy, should not be trivial, because Fx is half of Fc, right? And Fc is the length of the angle bisector. So one can find it. Okay? If you know how, I mean, there is a formula, not so specific for the angle bisector, but I will say discuss that. You can find Fc, then you can find Fx, and then you are done. Okay? This is what I am understanding. And so it boils down to how do you find the length of the angle bisector? Does anyone know how do you find the length of the angle bisector of a triangle? So there is a general formula. I don't quite forgot what the name is. Right? A good name starting with S. Stewart's formula. Anyone? Stewart's formula? Would have heard of it, right? At least you
Yes.
would have even seen it at some point. Maybe I've forgotten it. So apply the Stewart's formula. Otherwise, you will end up taking too much time. If you are going to find the angle bisector length by some other way, it would end up taking too much time. Okay, so just apply Stewart's formula and find the length of the angle bisector. Anyone remembers the Stewart's formula? Let's say in this setting, we have A, it cannot be A, that should be called C, B, and let's say that this is a MA and this is N, okay. M and N add up to 1. Now just splitting it. Then in this context, what's the Stewart's formula? Well, it's not difficult to derive. I don't remember it myself. Okay, but you can just look at any book, any just Google it also, you'll find it. Just, but it's very easy to derive it. Okay, so the idea is that we just actually just derive it. X, then this MA minus X. Just apply Pythagoras theorem, till you have enough equations. Okay, so AD square is what we are interested in. T, just T square equals to square. Just apply it till you have enough equations. Okay? But this is the formula. This kind of formulas you probably need to have for the exam. And then go the other, apply it on AEC. Okay, you get B square equals to MA. That becomes A minus X square. You see, plus AE square. Now you know what to do. Just subtract this equation. Subtract these equations, you have find the value of X. You don't have to solve any quadratic. You just find the value of X. You will see X square will cancel. That's it. It is true. It's not very difficult, and you should probably remember it. Okay, do it and remember the formula for the exams. Yeah. Today I'm probably not being very useful in the sense that I'm not finding any good methods. I don't know. There should be. Anyone has found? Upon last day you were finding some interesting ways, similarity and so on. Yes.
Yes, sir, what did you ask? I couldn't hear.
Is there a better way? I'm asking to all of you. You see, like without finding FC. A better way here means without finding FC. Because finding FE is trivial. There is nothing in finding FE. See, to find FE, we are not even finding AF and FP. In that sense, almost, right? Because we just need, see, to find FE is just FE by BC equals to AF by AB. And AF by AB, you know what it is, because it's AC by AC plus BC. Because AF by FB is AC by BC. Those are trivial things. Even those AF and FB, those you should know easily. So finding FE is simple, but finding FX is hard. So finding EX should be hard. You see my point, right? If finding EX was simple, then finding FX and hence FC would also be simple, but I don't think there is a simpler way to find the angle bisector length. Yeah, means actually find. And this 645 triangle doesn't seem to be special in any way. Is it special? No. So this, so it's maybe like that. You have to know the length of. See, one thing that I can say from the picture is AEDB is cyclic. I don't know how to use it, but AEDB is cyclic. Anyone can see. Cyclic is just this point, which is probably not useful in this question.
Sir, so we should find Fe and Fx, and then using Pythagoras theorem we should find Dx, right?
Yeah, should meaning that that's what I have done, but I have not seen a better way. But just this general extra observation is that this AEDB is cyclic. Can anyone spot that quickly? Right? So like this, you can see it in many ways. This angle is equal to this angle by parallel. And this angle equal to this angle. We don't need this. And that's why it's not a useful observation. This angle is equal to this angle. Can anyone see now why AEDB is cyclic? This angle is also or, or was it, is it not cyclic? Hmm. Should be easy. If it is true, it should be easy to prove. I can see it in one other way, but x, x, y, y, z. Hmm. So this is also x. Um,
So we'll get 2x plus 2y plus 2z, right?
Mm-hmm. 2x plus 2y plus 2z.
Yeah, that would be. No.
No. This we had proved that that thing is a rhombus. We have proved that that thing is a rhombus, FEC, but we should not need that. Okay, let me come to this picture. Oh, that picture is not there. Okay, let me give the reason that I had. Somehow with the angle chasing, I'm not able to do it. The reason I had is the following. This probably is also interesting. And let's see if it's correct. If it's incorrect, we'll find it. So we had this AF by F. Yeah, this you can see is equal to AE by AC. This has nothing to do with the angle bisector. It's just that FE is parallel to BC. So AF by FB is equal to this is what we have. But then this AF by FP is also equal to DC by BD. Okay. Right. And yeah, so it's not even cyclic. That's not correct. So yeah, let me try to show you the picture. Remove the unimportant things.
Sir, wouldn't it be cyclic only if AE equals to BD? If AE equals to BD, in that case, why is it cyclic? Sir, because AEDB is a trapezium and only isosceles trapezium.
No, it is not a trapezium, right? ED is not parallel to AB. That is not given. That is what we saw, right? The other two sides are parallel, but ED and AE are not. Okay. So what we have is this. We have this DC by BD. We have this DC by BD equals to AE by EC. So it is not similarity. Right? So at this point, we don't need the F thing. I'm trying to clear up the picture and show you the main thing. ED is not parallel to AB. This is what we're getting, right? DC by BD, okay, this by this, is somehow mixed up. So it's AE by EC. So yeah, in that way we don't get any similarity, do we? Right? No, it's just not there. Yeah. If you look at a similar situation, look at this following situation. If so, you can forget about this problem because we had some cyclic quadratic discussions. Maybe you can treat this as an extension of that. And maybe this is what we'll do today. This is the last few minutes. Is this. You see, if BD, if we had this, BD by so how do I want to say it? If BC by AC is equal to so then I'll just write this is equal to CA by CB. So I'll is equal to AC by BC. First, you look at this. It is a similar thing to this, but now you look at it. So it's like it just came in the context. I'm just trying to extend our knowledge of that cyclic quadratic spotting business. If we have this, look at this situation. DC by BC is equal to AC by BC. So it is like, you see, this DEC, right, is similar to ACB. Or that's wrong. DEC is similar to ABC. Okay, that is what this says, because there is a common angle and ratios are there, but there is a common angle. This angle is in common. I'll not, yeah, is common and be write DEC DEC. Okay, fine. That's what that ratio means. And from the similarity, you now get these angles. But what is that? This means this is cyclic. We have seen this. Right? It's because of various problems, it will not come out to be in the picture, but we understand. There is a circle passing through the 4 points, which is a nice thing and a non nice thing. It doesn't always happen, but it's very, very desirable. Right? So through ratios, you can also spot cyclicity. Okay? It's like we already knew this. I've just sort of extended the observation a little bit and told you, not telling something completely new. Okay? All right. So then we will stop. Yeah. So we did 3 problems. Okay, we took we learned a few things, but yeah, we didn't go as fast as.
Sir, I have like a sort of explanation why uh, a number ending 34 can't be a square.
Okay. Yes. What is that? Yes.
Sir, if we take like any number ending with like any square ending with 4 has to either be of the form 10n plus 2 or 10n plus 8. Like n can be anything.
It has to be 10. Okay. Right.
And when we square them, when we square 10n plus 2 and 10n plus 8, we'll get that both are 4 mod 20.
4 mod 20.
So because you'll get 100n square plus 20n plus 64 in the first case, and both 100n square and 20n are will be divisible by 20, but 64 will not be.
Right. No, that's correct.
64
Yeah.
will fall
That's
in
correct.
20.
Yeah, that's a good one. Okay.
And similarly, yeah, both will leave 4 remainder, but 34 does not, 34 is 6 mod 20.
Yeah, that's a very nice explanation. Very nice explanation. Yes. So as I see, the main thing here is I believe that this mod thing is not. These are all there. The main thing is that if it last is 4, then the number of cases is sort of very much reduced. Right? Then, yeah, since you already told the last digit is 4, then the last digit of the original number should be 2 or 8. And this is what I was missing. I was not able to think of this earlier in my when I was. Okay, I knew the answer is no, sort of, but that's a different thing. But I was not able to prove it in an easy way. But this is a very nice explanation, which is a very simple thing. If you look at the last digit of the original number, right? This kind of arguments have been used earlier. I think Ishan also many times has used the argument. So this is a very nice thing to spot in the right time. Otherwise, if you're like me, then not. Yeah. Still, I mean, I knew it by intuition, but that's fine. Okay. So this is it. When is the exam IOQM? I think Aparna and Ishan are writing. So when is this exam? What is the time?
Sir, I think it's from 10 o'clock to 1 on
Okay.
Sunday.
Okay, good. So we should have the class at 8. So please turn up. I think you will get the time to rest and so on. 8 p.m. And we can maybe discuss if you have the question paper or if you remember questions, it's good. I'll try to see if online I get the question. We get the questions, and then also it's fine. Okay, we'll try to discuss the paper. The IOQM is not as easy as NMTC is a very nice, good exam. IOQM is maybe slightly more selective. Okay? Do not think about all that. Okay, maybe give your best. That's all I will say. And give your best and see. That's all you can do. Okay? Yeah. I don't want to give any more advice. You guys, you take care of it. Yeah. Best of luck. Okay. All right. And see you on Sunday 8 p.m. Best of luck. And we'll continue this trend of solving these MCQ type questions. This IOQM we solve, then we'll move to AMC. Okay. AMC will try to solve. They also have some good problems. But yeah. See, give exam, you learn about yourself, about where you're weaking in the planning or in the subject matter or in the planning or whatever it is. And yeah. All right then. See you. Bye.
Bye.
Take care.